Nucleophilic addition reactions involve a nucleophile reacting in a carbonyl carbon. In this video, we'll look at nitrogen nucleophiles, which include ammonia, primary amines, and secondary amines. The reaction of an aldehyde or ketone with a primary amine forms an imine. Note that the imine has a carbon-nitrogen double bond. In biology, this ketone to amine transformation is one way that new amino acids are formed. So here's the mechanism of imine formation. So stop the video and use curved arrows to show how the imine is formed. So this is good practice of your organic chemistry skills, especially using curved arrows. The curved arrows show how the imine is formed. To get rid of the OH group, make it into a better leaving group. Bread, grilled meat, beer, cookies. Stop the video and think, what do these foods have in common? All these foods smell and taste good due to the most widely practiced reaction in the world. The most widely practiced reaction in the world is the Maillard reaction. So this reaction produces the color and those fabulous aromas and flavors in your favorite foods. In this reaction, a sugar reacts with a protein, which contains an amine, to form an imine. So stop the video and find the imine in this reaction sequence. So here's the imine. So that imine is an intermediate to form eventually these melanoidin pigments, which are responsible for the color and eventually the flavor and aroma. So here's the mechanism of the Maillard reaction. So stop the video and answer these three questions. So here's the tetrahedral intermediate. Here is the imine. Here is the hemiacetal. And what's wrong with step 3? The OH is a poor leaving group. The Maillard reaction is just one of 4 types of browning reactions in food. So caramelization, vitamin C oxidation, and enzymatic browning involved in fruits are the other 3. Scatol smells flowery at low concentrations, but smells like you know what at higher concentration. So how do you think the 2 reactants react to form the phenylhydrazone intermediate? So stop the video and think about that for a minute. So here's what happens. So the nitrogen nucleophile reacts at the carbonyl carbon to form an imine. So we know how a ketone reacts with an amine to form an imine. So let's look at the reverse reaction, the imine forming a ketone and an amine. Stop the video and answer these 4 questions. So here are the answers. The C-N bond is polar. The nitrogen has a partial negative charge. And for questions 2, 3, and 4, here is the reaction mechanism. So stop the video and practice using your curved arrows to show how bonds break and form. So the first step is a proton transfer step. Note that the 2 resin structures, this structure shows that this carbon is more electrophilic. And this step here, note that this is a good leaving group. And this mechanism is the reverse of the imine formation. Here is a biology reaction which involves imines. So stop the video, identify the part of the body this reaction occurs, and then, for as many reactions as you can, answer these questions. So here are the answers. Transamination is an important biology reaction which converts a ketone to an amine. We already looked at how a ketone is converted to an imine. So how is an imine converted to an amine? So is this reaction an oxidation or reduction? So this reaction is a reduction reaction. Transamination converts an aldehyde or ketone to an amine. PLP is converted to PMP, which is an important cofactor to help enzymes work. Here's how PMP works with an enzyme to convert this ketone to an amine in the transamination reaction. The structure of this intermediate is going to be an imine. So when an aldehyde or ketone reacts with a primary amine, an imine forms. What if A secondary amine reacts with an aldehyde or ketone. In that case, an enamine forms. So stop the video and use curved arrows to show how this reaction sequence occurs. Here is the reaction sequence. So stop the video and practice using those curved arrows to show how bonds break and form. So remember, practice makes perfect, so keep on practicing.